Today, kind of have a somewhat interesting topic, or a very interesting topic for me that I kind of want to talk about today, which is going to be the future of Avail, right? So, just to introduce myself again, I'm QEDK. I work in the explorations team at Avail, where I'm the senior R&D engineer there, where we're actively trying to kind of solve the interrupt problems on Ethereum as they are today, and not even Ethereum, but any particular EVM rollups, and even non-EVM rollups in the near future as well. So sort of let's delve into it, right? Like what do we have today that we sort of need to fix that isn't really working? And the fact of the matter is that the status quo today is fragmented. Liquidity is fragmented across multiple chains, multiple bridges. And what this effectively means is that the trades that can be executed at a much better rate, at a much better latency, they do not get executed at that particular pace, right? A very prime example of this can be seen on if you just go to L2 beat, right? You can see we have myriads of L2s and L3s today, probably even hundreds at the current rate of kind of building rollups via RAS providers and every other Avail provider that we have, right? And then we also have lots of bridges, right? This effectively means that interop between these bridges and interop between these particular L2s and L3s, they are more difficult, they're more fragmented, and which essentially means that the UX that we kind of want for a user to experience in Web3, it's not quite there, right? So what can we really do to sort of alleviate this to some extent? And to kind of delve into what the issue is, maybe what we can start off with is the typical cross-chain bridging experience, right? If today you have to go from a chain like Optimism to a chain like Arbitrum, what that kind of boils down to is you lock your assets in Optimism, and then you mean consequently different assets on USDC, which on Arbitrum, which is like representing a different asset. And then to sort of complete the flow, you have to burn those assets on Arbitrum and then unlock them in Optimism, right? And this is the typical cross-chain bridging experience today. If you're not using trust, not rather like centralized protocols like across and myriads of others like dBridge or even Layer 0, which all typically have validator or multisig based setups, which are not trustless at all. And so now if we draw a comparison to something that we have in Web 2, effectively you go to Amazon, you really want to buy your video game, you really want to buy a pillow cushion, and then you just pick your item, and then you go to PayPal, you sign in, and then Visa just processes that particular transaction in the background, right? You really don't worry about anything else apart from approving that particular transaction in PayPal, and it's that easy. It doesn't really matter where your assets are, it doesn't really matter which card, it doesn't really matter which bank, it just works for you. And that's sort of the experience that we want to emulate in Web3 as well. So what we kind of want to delve into now is sort of an ideal world, right? An ideal world where there are two highly specialized chains. We have an NFT marketplace chain, which is only tracking NFT ownership. And then we have a payment chain that is only tracking balances, right? So when you talk about a chain like this, effectively you can think of it like an OpenSea chain or a Blur chain, where all your BAYCs and all your MAYCs are living. And then consequently, you have a payment chain that is kind of just keeping track of how much money you have, which is similar to your bank. And it's effectively like Polygon or Optimism or any other rollup that you kind of want to use. And in this ideal world, all you have to do is you go and place a trade on your NFT marketplace chain for your BAYC or MAYC, right? You find it really funky and you really want to make a trade. And then as you click to buy it, you're directed to a payment provider, right? It doesn't matter what payment provider it is, because that's how the system is designed to work, because the user shouldn't really care as to what payment provider it is, and it's something that should just work for them. And in this ideal world, after you've made the payment on the payment chain, you go back to your marketplace and you just get your NFT. And that is how every e-commerce transaction works today. And that is the behavior that we should be emulating in Web3. So how can we make it happen is sort of more of the typical questions that we get, right? And there are multiple ways around it. We'll discuss a few today. And this is where we kind of introduce a solution called Avail Nexus. Avail Nexus is effectively designed to be a trust-optimized rollup interoperability protocol, right? And what this is sort of going to entail is that it's going to be a precursor to chain abstraction. So let's say that you're someone like Arcana, who is building chain abstraction infra, or even across, who is kind of transferring assets using solvers across chains. You can simply leverage Nexus And you'll get a lot of these trust optimized properties automatically on your rollup. And some of them you don't even need to deploy in Avail DA. And the idea behind that is that we want it to be a trustless protocol. We want to be a trust minimized protocol. And then if you want even lower latencies, we can make it a trust optimized protocol, right? And effectively, what Nexus boils down to is that it is a permissionless interoperability protocol, right? And what that means is you can actually unify rollups by actually enabling communication at scale, right? If you're Arbitrum, if you're Optimism, how can we have them talk to each other at scale? How can we have them talk to each other efficiently? That is sort of the problem that we want to solve. And primarily, it has four facets to it. They're going to be asynchronous composability. We have a validity proven slow path. We have a trust optimized optimistic fast path. And then finally, what matters is that they are secured by Avail DA. And I guess the primary factor that we have now is that we have the Avail L1, which has always been known for DA, but we are going to embed something called a Nexus runtime into the Avail L1 that allows us to verify those Groth16 proofs at scale and allow you to interrupt between these chains trustlessly almost. And that kind of drives us to another factor, which is what really secures rollups today, right? And the fact is that rollups typically have two components which need to be verified. One is going to be data availability, and the second is going to be execution. And typically, when you talk about EVM rollups today, they have two elements or two facets to this execution proofs, which are either going to be fraud proofs or validity proofs, right? Fraud proof chains are typically what we call optimistic chains. So they're going to be your Arbitrum base, Optimism, and then on the validity proven end, we essentially have what we call ZK proofs. I believe validity proofs are more accurate, but effectively your chains that kind of get finality in an hour or 2 hours, typically ZK sync era, Polygon, CDK chains, ZK AVM, and so on and so forth. And what this sort of boils down to is that without DA guarantees, rollups are not secure, right? Because either the safety or the liveness protocol of a rollup has to be violated if you do not provide those additional DA guarantees. And that is something that we kind of provide at Avail as well, where we are saying we have KGG commitments, we have validity proofs. If you are able to make a verifier that kind of takes the validity proofs and verifies them as well, then you also have DA guarantees that are inbuilt into your rollup. But sadly, it's a bit difficult on Ethereum today because the trusted setup ceremony is different. The padding of the cells are different. But if you're a sovereign rollup, this is something you can actually do today. And in a way, it's arguably more secure than the L2s and L3s of today. And let's talk a little bit about how cross-chain interop today typically is. Let's say we have a chain 1, we have a chain 2, and then you really want to interact. What this is going to boil down to is you're going to run light clients and full nodes of your chain, and that's how you're going to interact, right? So if you're a solver, what that basically boils down to is that the more chains that you have, the more full nodes you'll be running. And this essentially means that the cost of running a solver and the cost of doing interop is something that scales super linearly, right? Because you keep having to run more and more infra. And this is not great, right? Because this is not efficient, nor is it something that is trust minimized because you have to rely on full nodes. And a lot of the solvers today, they actually rely on RPCs, which means that you're actually trusting a centralized service, not even a full node for the same amount of data, which means that the trust guarantees and the security assumptions of the system are much, much lower than what it really should be. And that's where we're positing what ZK Nexus can be. Again, ZK Nexus is just one facet of what we're doing at Avail and as part of Nexus. But effectively, what it boils down to is that let's say a particular ZK chain, again, when I talk about a ZK chain, what I'm referring to is a validity proven L2 or an L3. So you have ZK Sync Era, you have ZK EVM, you have Starknet, or you have X other ZK L2s, right? And for you, it should be as simple as you have your settlement proof that is already generated via your GPU prover typically. You run an Avail LC where you get your validity proof guarantees. And then you have a Nexus adapter that you write for each of these rollups. Again, you only need a separate adapter if the proof system is different. For the same proof system, you can just reuse the adapter. The adapter essentially takes your settlement proof and enshrines a verifier within Nexus. And your rollup state can be updated by just updating the state of your chain within Nexus. So the canonical view of a particular chain is something that lives in the Nexus runtime on Avail. And using the particular state roots that you commit through the verifier, we can now do trustless interop or trust minimized interop that is much faster and much lower latency than what it could be today. Of course, I don't mean optimistic setups, but in validity-proven setups, it is something that is much more efficient, right? Because instead of submitting separate proofs for each rollup, we can compose all of these proofs that come from the adapter, and using RISC-Zero's aggregation circuits, we can actually make it much, much faster than what it is today. And a brief example of this would be the contingent execution via ZK Nexus, right? If you remember earlier, I sort of showed you a graphic where you sort of purchased your NFT, your BOIC on the OpenSea chain, and then you paid on the Polygon chain, right? And this is enabled by something called contingent execution. What it effectively boils down to is that, let's say you make a particular transaction on chain 1, you can ensure 100% that a particular transaction can or cannot take place on chain 2. And again, this is secured by validity proofs. So you know for sure that the state that you're going to get on chain 2 is going to be correct, depending on the execution of the state on chain 1. So if you walk through this flow diagram, what you'll see is you have a particular user who's reserving their NFT on the NFT chain, right? And you make your payment on the payment chain. These are two separate transactions that technically either of the chains don't really know about, right? But then Nexus will get a proof of payment inclusion from the payment chain, and which means that the NFT chain can now infer, based on the state change on Nexus, whether that payment was included or not within a specified time frame, which basically means that we can now have a contingent execution on the NFT chain, which can cancel or confirm the NFT transfer based on the inclusion or non-inclusion of the payment. And this is something that ZK Nexus enables today. And this is something that will actually, I believe, reduce the trust guarantees that we kind of place on chains today, which is what we also want to solve, right? We also have sort of other elements to it. We have something called OP Nexus, which is sort of a more of an order resolution guarantees, right? So when you talk about ZK Nexus, since we're enshrining this with Nexus, we have a verifier for each chain within Nexus. What this means is, since they're enshrined, we can provide chain security guarantees, right? What this means is, as soon as your proof goes through the adapter on Avail L1, we know for sure what the state root of the chain is going to be, and we can have trust minimized guarantees. So that's kind of what we want to build at Avail, where we essentially want to make these modular chains unified, right? When we talk about modularity, what we mean is roll-up components typically have three aspects to it. One is going to be execution, consensus, and DA, right? I mean, of course, we have settlement as well, but the concerns of a settlement are sort of something that we don't tackle in modularity, but it's something that can efficiently be done in most places which have a generalized VM language, which is going to be Ethereum, Solana, or X others, right? And the idea that we are kind of positing today is that if we have n modular chains, and if you use Avail DA with ZK Nexus and the power of proof aggregation, and as long as you're running a light client, we can have virtually trust minimized and even trustless guarantees that would not be possible elsewhere, right? And let's say that these rollups typically do not get access to liquidity, or they want to run sequencers. We also have a solution called Fusion, which allows rollups to kind of borrow liquidity from the Avail L1, and that is going to secure the rollups as well, right? This is typically if you want shared sequencing, or you want to kind of protect your sequencer with cryptoeconomic guarantees as well. It's something that we can enable with Fusion in the near future, probably in like 8 to 12 months. So if you remember the Amazon-like experience that we spoke of earlier, where you were checking out your video game, you're checking out your pillow cushion, what this means is that emulation of the experience where you just use PayPal and it just works, and then Visa settles in the background. And Web3, this is what's going to look like. Where you make your transaction on OpenSea, your assets are transferred on Optimism, Avail just processes it in the background, and then your payment goes through on Polygon. And then your NFT is just there, just like that. And that is sort of the future that we see, where with our suite of solutions, which we're calling interop apps, of which we have ZK, OP, and TEE, we can actually make interop much faster. And I think the coolest part of this is that rollups can actually make a choice, right? If a rollup wants to have faster latency, and if a rollup, for example, has a lot of short tail assets, right, they will not enjoy having like a 1 hour or 2 hour wait, right? Which is where we have solutions like OP Nexus that work, which actually allow order resolution guarantees using cryptoeconomic guarantees. And yeah, that was it for today. That was Avail. Glad to be here.